EIGRP configuration. So this is topology R1, R2, R3. R1 LAN is 192.168.1.0. R2 LAN is 192.168.2.0. R3 LAN is 192.168.3.0. Between R1 and R2, 192.168.12.0/24. Between R1 and R3, network is 192.168.13.0/24. Between R2 and R3, network is 192.168.23.0/24. Now we will configure EIGRP. So before that, first we need to configure interfaces. Okay, in R1 we have three interfaces: F0 by 0, F0 by 1, and F1 by 0. So I will configure in Notepad. Later we will execute this configuration. Okay, in routers. Enable configure terminal hostname R1 interface F0 by 0 IP address 192.168.1.1 255.255.255.0 description connected to LAN no shutdown exit F0 by 1 F0 by 1 IP address is 192.1.12.1 and this interface is connected to R2 and next interface F1 by 0 IP address 192.1.13.1 and it is connected to R3. Okay, this is the R1 configuration and copy this configuration and edit it. Okay, for R2 host name is R2 F0 by 0 192.1.2.1 description is same and F0 by 1 IP address 192.1.12.2 and the description connected to R1 and F1 by 0 IP address 23.1 and it is connected to R3. Okay, correct. And next R3 interface F0 by 0 IP address 192.1.3.1 and F0 by 1 IP address 13.2 and it is connected to R1 and F1 by 0 23.2 and it is connected to R2. This is configuration. So copy this configuration, copy, paste in router 3. Copy R2, R1. From here, copy CLI So what is the first step? So after interface configuration, the first step is, okay, first check the interface status. Remember this point, okay? So whenever you implement new topology, before configuring protocol, first check the layer 3 connectivity between routers. Okay, whenever we implement new topology, first check the layer 3 connectivity between the routers before configuring any dynamic routing protocol, okay? Or even static routing also, okay? Right, so how to check the connectivity? From R1, ping R2, R2 IP 192.168.12.2, and also ping R3 192.168.13.2. Okay, see here, I am pinging from R1 from privilege mode, ping 192.168.12.2. It's pinging, ping 192.168.13.2. It's pinging, right? It's pinging. So we have a connectivity between routers, and try to ping from R2 to R3, and do ping 192.168.23.2. 23.2 is here, it is not working. Oh, sorry. Uh, 23.2, right? Okay. Yeah, see, we have a connectivity. So now configure EIGRP. EIGRP configuration is very easy, same as RIP protocol. Same. Here also we need to advertise directly connected networks. Okay. So in R1, what are the directly connected networks? So in R1, directly connected networks are 1.0, 12.0, 13.0. See here, if you see the routing table, it shows directly connected networks. Go to here, show IP route. See, it shows directly connected networks. Now advertise these three networks in EIGRP. Command is router EIGRP, and here we should mention autonomous system number. Autonomous system number can be any number between 1 to 65,535. Here you can use any number. See here question mark, okay? Here if you put question mark here, see number range is what? 1 to 65,535, okay? You can select any number, but this number should be same between neighbors. Remember this point, keep in mind. This autonomous system number should be same between neighbors. So here I am selecting AS number 100. And next, network 192.168.1.0 and 12.0 and 13.0. That's it. This is EIGRP configuration. Same as RIP protocol. But the difference is here, EIGRP is configured with autonomous system number, RIP, no autonomous system number. RIP, in RIP we have versions, in EIGRP we don't have versions. Okay, and configure R2 and R3. First see routing table, it shows directly connected networks, and then advertise these networks into EIGRP. Okay, it is very easy. Router EIGRP. These numbers should be same, 100 and 192.168.2.0 and 12.0 and 23.0, right? And save configuration. Now come to R3. Do show IP route. Router EIGRP 100. Network 192.168.3.0, 13.0, 23.0. See here, we got neighbor relationship message, right? Okay. Now we have configured EIGRP. What is the first step? After EIGRP configuration, check the neighbor table. The command is show IP EIGRP neighbors. This is the command. Okay. So for R1, how many neighbors are there? For R1, R2 is neighbor, R3 is also neighbor. So for R1, 192.1.12.2 is neighbor, 192.13.2 is also neighbor. Okay. So now in R1, in privilege mode, command is show IP EIGRP neighbor. See, neighbor, it's showing 192.168.12.2 and 192.168.13.2. Neighbor is there. Next check the routing table. Show IP route. Show IP route EIGRP. See, these are the EIGRP networks. Here code is D. D is dual algorithm. 192.168.2.0/24. In the bracket, the first value is administrative distance, the second value is metric. First value is administrative distance, second value is metric. We will discuss about this metric, okay? How this metric came. We will discuss that later. And via 192.168.12.2 and interface is fast Ethernet 0x1. This is outgoing interface to reach 192.168.2.0 network. This is the routing table. And 192.168.3.0 network received from 192.168.13.2 on fast Ethernet 1/0 interface. Okay, see 2.0 network received from 12.2, 3.0 network received from 13.2. Correct, right? See, as per this topology, R1 has received 2.0 network from this neighbor and 3.0 network from this neighbor. Correct, right? Now, see router to routing table. First, see neighbor table. Show IP EIGRP neighbor. See, here also we have two neighbors, 12.1 and 23.2. 12.1 is R1, 23.2 is R3. Now see routing table. Show IP route EIGRP. 192.168.1.0 network received from 12.1. 192.168.3.0 received from 23.2. Correct, right? And R3. Show IP EIGRP neighbors. Neighbors are there. Two neighbors are there. R1 and R2. Show IP route EIGRP. 192.168.1.0 received from R1. See 13.1. 13.1 is R1. This one. R3. R3 received this network via this way. And also 2.0 via this way. Via 23.2. Sorry, 23.1. Perfect, right? This is how to configure EIGRP. How to configure EIGRP. And if you try to ping from R1 LAN to R2 LAN or R1 LAN to R3 LAN, okay, we can successfully ping. Okay, see here. First configure IP address on systems 192.168.1.2 gateway 1.1. And here 192.168.2.2 2.1. 92.168.3.2 gateway 192.168.3.1. So now try to ping from R1 LAN to any other LAN. Okay. So here ping 192.168.1.2. Sorry, 2.2. See here, we are getting response, right, from 2.2. If you check path, TRACERT 192.168.2.2. See, the first packet reached to 1.1, from there 12.2. 12.2 is R2 IP address, right? So this path. For example, see here, I will show you convergence here. For example, I am pinging 100 packets, okay? -T, continuous ping. Oh, sorry. Okay, I will ping 1000 packets. Okay, okay, 1000 packets. See, it's pinging, right? And while these pieces are communicating, if primary path is failed, this path, if this path is failed, see here, we cannot see any single drop. See, no drop. There is no any packet drop here. Why? Because RIP convergence is very fast here. See here, if you see the routing table, show IP route. See, route changed here. 192.1.2.0 network. Now, uh, reachable via 13.2. This path. This path. See, there is no any single drop. So this is the EIGRP configuration and testing. Okay.